Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. This week's video is the first in a series made in collaboration with the Space Architect Technical Committee as I explore space diapers. Let's check it out. When we think about diapers, we usually think of babies. After all, most of us wore them as infants, and maybe now our younger siblings or friends' siblings use them too. But did you know that astronauts also wear diapers sometimes? These are special diapers, and they are called maximum absorbency garments, MEGs, and astronauts wear them when they have to stay in their suits for a long time, like during spacewalks or while their spacecraft is re-entering Earth's atmosphere. Just like with baby diapers, the most important job of an astronaut diaper is to prevent leaks. But have you ever wondered how diapers actually work? What's inside them that lets them soak up all that stuff and still stay mess-free? That's where science and even space architects come in. Space architects help design spacesuits, including the inside parts like MEGs, to make sure astronauts stay comfortable, safe and dry during long missions. In this activity, I'll explore the amazing material inside diapers that makes them work so well, whether it's in a baby's crib or out in space. For this activity, you will need 8 plastic cups, measuring spoons or a teaspoon, fake snow, food colouring and a marker pen. Alternatively, instead of using fake snow, you can cut through the inside lining of a couple of diapers and collect the cotton-like stuffing material inside. This and fake snow are both made from the same substance, sodium polyacrylate. First, I'm going to label 4 of my cups, one to say 1/8 of a teaspoon, another to say 1/4 of a teaspoon, a third saying 1/2 a teaspoon, and the final one saying 1 teaspoon. Into the 4 other cups, I'm going to add 1/3 of a cup of water to each of these, as well as a couple of drops of food colouring into each cup. Next, I'm going to use measuring spoons to add different quantities of fake snow into each of my labelled cups. So in one there will be 1/8 of a teaspoon of fake snow, in the next 1/4 of a teaspoon, then 1/2 of a teaspoon, and finally 1 whole teaspoon. Starting with my 1/8 of a teaspoon cup, I'm going to take one of my cups of coloured water and gradually pour this into the cup with the fake snow and watch for any changes that take place. I'm going to repeat this procedure with my 1/4 of a teaspoon cup, then again with my 1/2 of a teaspoon cup, and finally with my whole teaspoon cup. Now that I've added the same volume of water to each of my cups, I'm going to line them up side by side to compare the changes in each cup. As I added more powder to each cup, you probably noticed the amount of the mixture grew. I also noticed a change in the texture of the powder. Once there was enough powder to soak up all the water, it transformed from tiny crystals into soft jelly-like particles, like little round grains of rice. That's exactly what we'd expect to see happening. The powder, called sodium polyacrylate, is a polymer, which means it's made of chains of repeating building blocks called monomers. These superabsorbent polymers swell up when they touch water because the water gets pulled into and trapped by the polymer molecules. In other words, sodium polyacrylate works like a super sponge. This is the same polymer that is used in the maximum absorbency garments used by astronauts. Their spacewalks often last 5 to 8 hours, and they can't just stop for a toilet break, so it is essential their needs are met during these times. The MEGs are not like typical diapers though. They are more like bike shorts that astronauts wear, and they draw urine away from the body. These space diapers can absorb up to 2 litres of urine, and if needs be, astronauts can go 8 to 10 hours without needing a change. You can extend this activity by changing the amount of sodium polyacrylate or water you use, or try adding a teaspoon of salt to your final mixtures and seeing what effect that has. Well, that's all for this week. I hope you enjoyed it. A big thank you to the Space Architect Technical Committee for partnering with me on this series of videos. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. Also, if you've got any questions that you would like to ask a space architect, feel free to send these through to stemwithmrn@outlook.com, and if we get enough through, myself and the Space Architect Technical Committee will make a video answering your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demo and explanation videos I do, here to my series of STEM career interviews, and here to my brand new series of science fiction to science fact. This has been STEM with Mr. N, exploring space diapers.